So we're going to use inward as positive. So we're going to say T plus mg equals mv squared over r. So then the tension is going to be mv squared over r minus mg. That should make sense to you because gravity is trying to loosen, like make the string less tense. It's trying to push the ball towards the center, which would make it squishy, sort of, using scientific terminology. So we know everything. So then it's just a function of m times v squared over r minus g. So that's going to give us m, which is v squared over r. Okay, 2.9 says 3. 2.9 squared divided by 0.8 minus 9.8 times 0.3. That's going to give me a tension of 0.214 newtons. So the tension at A is 0.214 newtons. Now, I'll go in yellow. Sum of the forces in x is equal to mv squared over r. And then there is no force. There's only tension because gravity points straight down. Okay, so that's not really affecting it. So T is equal to mv squared over r. And what we have to do is if this had a velocity of 2.9 up here, and we know r is 0.8, then I have to use gravitational potential energy. So you have to use MEI equals MEF, and then we get KEI plus MGH rather than KEI. Let me just say 1/2 mv squared plus mgh is equal to 1/2 mv final squared. And then in this case, we're going to set that as 0, so there's no more potential. So that's 0. It's just that all becomes kinetic at that point because we're just talking about this part. The masses obviously cancel. V is equal to the square root of v0 squared plus 2gh. So 2.9 squared plus 2 times 9.8 times 0.8. That gives me a speed of 4.91 meters per second. So I plug that in there, and the tension is equal to 0.3 times 4.98. Keeps dying. Had to get a different calculator. So this says the square root of 2.9 squared plus 2 times 9.8 times 0.8. Oh, okay, I already did that. It's 4.9. So now it's the tension is 0.3 times 4.91 squared divided by the radius of 0.8. It's going to give me 9.03 newtons. Whoa, that's massive. Okay, that's humongous. If we were to find TC, I could do this once more.
To share it to.
And that's going to be TC, if I do the sum of the forces, just a second, in the y is equal to mv squared over r. So then we're going to get T, this is pointing up, minus mg, because it's pointing down, equals mv squared over r. So then our final statement will be T equals mv squared over r plus mg. And then we can also use let's do it all over.